Hi, my name is Adithya Kumaranchath. I'm a principal engineering architect in the Azure Data product group. So my talk is going to be about migrating very large Oracle databases to Azure Database for PostgreSQL. So if you're a decision maker or if you're looking to migrate to Azure Postgres, then this talk might be interesting for you. So let's get started on migrating very large databases from Oracle to Azure Database for PostgreSQL. So, a quick rundown of the session for the next 20 minutes. So, I completely understand that 20 minutes is going to be a really short time to deep dive into all of these topics. And what I intend to do from this session is give you pointers and checklist, a quick checklist, which you can keep in mind when you are migrating your Oracle workloads to Azure Database for PostgreSQL. So over the past years, customers have always come and asked me this question: What is that? What are the things that I need to think of when I'm migrating large databases to Azure? Because migrating large databases to Azure is not easy. One is the size of the data. Of course, there is there's that bit which is usually challenging, moving all of that data across. But also, what is to be bear in mind is the complexity of the database code itself. So when you're moving to a managed service like Azure Postgres, you also need to understand how to size it properly and how exactly to ensure that you get the right level of performance. So I'm sure many of my colleagues as well have talked about these topics. So why do customers move to Azure Postgres and Azure, of course? So first of all, it is to adopt open source because there is no license cost. It's a community-driven software. PostgreSQL, as you know, is one of the most leading uh, community dif- uh, community-dependent open source software out there, and it's one of the leading technologies. Customers can reduce costs. For example, if customers are running Oracle workloads, then obviously it's going to be cheaper for them because they're going to avoid license costs in Postgres. They avoid vendor lock-in as well because if you're running PostgreSQL, then of course you can move to other clouds as well, not just in Azure. So and then there is manageability side of things. So when you're moving to a platform as service, the backups are going to be managed by Azure. The updates and patching are going to be managed by Azure. So all of these tasks that you used to do in an on-premises environment, which you used to do manually, are all going to disappear. So that becomes much easier to manage. Then comes the interoperability. So there are a lot of extensions which PostgreSQL offers, which you could use in your development. You can, for example, right now AI is a big buzzword in the industry right now, and there are a lot of extensions which will enable AI use cases and lets you adopt those technologies. Then the other thing is community and ecosystem. PostgreSQL, as you know, is heavily community driven and helps you adopt those changes at a faster pace, and helps you get assistance as needed from the community. So these are some of the reasons why customers choose to move to Postgres from Oracle. But the move to Oracle doesn't come easy. There's always a lot of challenges when you're moving from one database technology to another. um, these are a few challenges that you would have to keep in mind when you're moving from Oracle to Postgres. One of the key challenges is schema compatibility. So, for example, the changes in constructs in Oracle versus the change of constructs in PostgreSQL. So you have different data types in both of these database engines. We need to bear in mind that these are two database technologies and they have starking differences. So and if you are running a very large database in Oracle, then over the years you have accumulated a lot of database code, which means you have a lot of packages, you have a lot of procedures, and moving all of those database code to PostgreSQL is going to be a complex task. Fortunately, we have tools to do that. We have tools like Oracle PG to do that, but this is something that you have to keep in mind when you're moving a large database, because the amount of code that you have in your database can lead to complexity. It can lead to increase in the migration timelines. Of course, when we talk about large databases, the data itself is a challenge. Imagine you have multi-terabyte database and moving it from on-premises to Azure. It's going to take a lot of time, and it's going to take proportional to the size of data you have. Now, that itself is a challenge, and doing that efficiently, doing that in a way that meets your downtime SLAs is something that you need to keep in mind. So, at the start of the migration, these are a couple of things that you need to basically list them down and keep in mind, so that you can handle them efficiently. For example, if you require a low downtime migration, then imagine migrating 30 terabytes of data over to Azure, it's going to take you a few days. And it is going to be dependent on the network bandwidth between your on-premises infrastructure and Azure. And so in order to achieve a low downtime, you need to ensure that you plan this migration in a structured fashion. And luckily, we have tools to do that. But then it's all about planning so that you don't have any surprises and you are able to move this data efficiently. Well, cost is one of the key reasons why customers move to Azure Postgres. But at the same time, um, the cost becomes a moot point if performance is not met. So meeting performance is one of the main points for customer. So having a predictable performance is also something that customers expect migrating migrating to a new database as service. Now that can be challenging because of the size of the data, because of the complexity of the code. So that is something that needs to be kept in mind as well when you're migrating to Postgres. Um, the other thing is right sizing. So because you're moving from an on-premises infrastructure, which is usually over-provisioned, you're moving to Azure Postgres, which is a managed service. So you need to size it accordingly so that you get the right level of throughput and right level of IOPS. So that is something that needs to be taken care as well. Luckily, we have tools to do most of these tasks, and we have tools like Shrim, which can replicate data from Oracle to Postgres in near real time, which can help you with migration. And many of our customers use tools like that in order to achieve that near downtime migration. So I'll talk about that in a bit when we cover customer stories. But it is fortunate that we have tools to help us with these kind of migrations. The other important thing is managing maintenance of the database itself. For example, how do we manage the table bloat? How do you manage the cleaning up of the database, monitoring of the database, and scaling of the DB? That's also an important thing to keep in mind when you're migrating large databases, because as you know, the data size the data growth can be significantly faster in a large database, which means that you need to run those maintenance tasks more periodically without being invasive to the production workload. So that's something to keep in mind as well. So I think the best way to explain this would be to explain it through a story. So basically, I'm here to talk about a large bank in Europe who migrated their Oracle workload to Postgres. In the beginning, they were a bit skeptical because they were an Oracle friendly customers and they had tons of experience with Oracle. They ran many databases in Oracle. So moving to Postgres, they were very skeptical about it, and but then after seeing that they could um, reduce their costs both from a license perspective as well as from an operational perspective, they decided that they would like to try that approach. So they started off with a POC, which they ran for a few weeks, and then they did some performance tests. And as part of the POC, they uncovered a lot of challenges. So if you're looking to migrate a large database, the first step would be to do a POC. So basically, start by migrating the data. Start by first converting the schema. That would be the first step, and then migrating the data, and then run some performance tests and see if you're meeting the performance that you expect in the new database. The challenges that they had was mainly with data types and partition. So, as you know, Oracle and Postgres have different partition schemes, and the handling of those partitions are automatic in Oracle, but then in Postgres they have to be manually handled. So they had challenges there, but they were able to manage it pretty efficiently using PG Partman and other extensions that are there in Postgres. And they did have a lot of performance issues when they migrated to Postgres, but then it was just a matter of tuning the system because it's a new database engine, and um, it's expected that there will be some performance issues. So they had slow initial load data performance, and their batch loads, which used to take a few minutes, were spanning to hours, and they had to sit and spend a few cycles in order to tune the performance and ensure that they got the performance that they expected. So the best approach that they took was that they did a phased migration. So although their data size was somewhere around 16 terabytes, they what they did was that they first migrated part of their data, which was kind of an archival data, in a retrospective fashion. And what they did is that they migrated the live data. They used tools like Stream to migrate the live data and to keep both the source and the target in sync. That actually helped them in achieving a near zero downtime cutover, because by just keeping the live data in sync, they were able to manage the transactions from their live applications and cut over successfully. Another interesting bit was parallel data loading. So they had partitions in Oracle. They aligned those partitions in Postgres and loaded the data in parallel using services like Azure Data Factory. So Azure Data Factory is an ETL tool, cloud-based ETL tool, which you can use to load data from Oracle to Postgres. And what this customer did was that they created copy pipelines um, and loaded these partitions individually. And because these partitions are individual tables, they could get performance, much higher performance, because these data loads were happening in parallel. So that's something that's interesting, I felt, because that way they were able to copy the data more efficiently. One of the things that worked really well with this customer was their focus on testing and tuning. So, like I said, because Postgres is a different database engine, it is expected that after migration, there will be some performance issues, and it is expected that some of the queries which you fire against the DB doesn't work as expected. So in that case, the customer took some cycles and ensured that they did the tuning exercise where they identified the top queries from their Oracle environment, and then they benchmarked it against the newly migrated PostgreSQL database, and then they started tuning those queries. And that exercise, they actually, I think they spent at least a couple of months in doing that exercise, and they did at least 4 or 5 tuning cycles where they continuously tuned the queries that they found not performing up to mark, and they kept on refining them until they achieved the performance that they expected. So these are some of the key learnings from that migration that I repeatedly use with my customers. Um, because what I understand is that there's no way to migrate a large database without complexity. It is going to be complex, but then the way to break that complexity would be to do it in phases, so that you're able to meet your timelines. So the key things that the customer achieved was because they had a phased migration approach, they reduced the migration downtime. they had a few minutes of downtime, and the downtime was only during the cutover period when they cut over from their Oracle database to the Postgres database, and the performance was actually surprisingly much better than Oracle. It's not actually a surprise, because in most of the cases, from my experience, after migrating to after migrating to Postgres, it is generally observed that the performance of the queries is much better than Oracle. And the customer also found that they had a lot of cost savings after migration. So a typical migration lifecycle starts with schema validation, and you would do the POC at the beginning of the migration, a few weeks beginning of the migration, and the first step would be to convert the schema using tools like Ora to PG. Ora to PG is an open source tool which is used by many customers to migrate their schema, to convert code basically from Oracle to PostgreSQL, so PL/SQL to PG/SQL, and that's the first step of migration. And once you have converted the code, then you can deploy the schema in PostgreSQL. And one of the key things would be to identify what the target cost would be, as in how much cost you would be uh, incurring when you move to Azure Postgres. And you can do that only if you know what's the SKU size, what's the compute size that you're going for. And that would be the next step. So identifying what is the right SKU size in Postgres, so that you can plan your production environments. And in order to do that, you need to identify what kind of val throughput you need, what is the storage layout, what level of IOPS do you require. So those are a couple of things that you need in order to determine the SKU size. And the starting point of that would be to analyze the AWR report from Oracle. So if you're running Oracle workloads, then you can get the AWR report during the peak workload times, and identify what's the IOPS requirements, what's the CPU utilization looking like, and those are basically clues for you to determine the right SKU size and plan the target architecture in Azure. And once you have the schema converted, then it's about loading the data. And loading the data would be done through either you could use Azure Data Factory, tools like Azure Data Factory, which is a first party service to load data in Azure. It's an cloud-based ETL tool, or you can rely on other tools in the market like Strim, which you can use to load data in parallel. And here you could leverage the partition based data loading as well. So if your Oracle tables are partitioned, and in Postgres, when you create the tables, you create them as partition tables, and then you could load the data in parallel into those partitions. That way you can load the data faster. And if you need a low downtime migration, then in that case, you would use tools like Strim, which do real time or near real time replication from the source to target. And that can help you keep the source and the target in sync for an extended period of time. And after you're done with that, you basically do a round of validation, performance testing, and then tune the queries which don't perform the way you want it to. And then once you're done with the tuning and testing, you basically cut over to the new environment. So that's how a typical migration looks like. Some of the important points to consider when you are doing large database migrations. So first of all, like I said in the initial bit, as the data grows, the complexity also grows of the database also grows. So something to keep in mind: if you have a huge amount of code in your database, then obviously you need to factor in that time so that you are able to migrate it across. The other thing is the partitioning. So if you have a lot of partition tables in Oracle, you probably have to redesign the partitioning strategy in Postgres, because the partitioning strategies are very different in both of these database engines. So keep in mind and ensure that you define this before your migration, so that you're aligned with respect to partitioning. because once you change the partitioning, there is a possibility that some of your queries also have to be tuned and changed, because the partitioning strategies are quite different in both of these database engines. Another challenge that we keep witnessing is lobs. I mean, if you have a lot of lobs in your database, then that is going to be a challenge for sure, because transferring lobs is going to take a lot of time, and it is not efficient. So um, the right way, or the the best way to do this would be to run a query, find out how many lob tables you have in your DB, and keep them separately and migrate them separately, and define a strategy to migrate them separately. A good thing about migrating to Azure would be, see if you can move those lobs to an Azure storage rather than storing it in the database itself. That is one good mechanism to also re-architect in a way, or redesign your application efficiently. So because once you move those lobs to an archive storage or a storage outside of Azure, then your database size is going to be smaller, your backups are going to be faster, your queries are going to be more efficient. So think about that. If there is an opportunity to do that change, then go for it, because that's going to help you make your queries go faster. And the other important point is val generation. So you need to ensure that you take in account for this and tune it accordingly, so that you are in the right SKU in Postgres. Some common pitfalls when it comes to VLDB. So as the data size grows, the table size also can grow, so which can lead into table bloat. As you know, Postgres follows an MVCC pattern, which means that it keeps the old version of rows in the table, and this can lead to table bloat. And having a bloat in the tables, which means that your queries are going to be slower, and it is going to cause performance issues. So keep in mind, when you have a large DB, if you have ingestion processes which can cause this, then ensure that you avoid the table bloat. The one of the other things is auto vacuum, which can be stalled. So in order to clear the table bloat, the vacuum process has to run periodically. You need to plan this so that your maintenance tasks run efficiently. So these are a couple of challenges which is quite common when a database is large. Um, Slow copy performance can also be one of the other things which customers usually don't pay attention to. So if you have ingestion processes which load data in bulk, think about using copy. Think about tuning the copy performance. That's something that you have to keep in mind, because this is something that is overlooked repeatedly. And the last thing would be skew sizing. So sizing the compute according to your workload pattern is very important when it comes to a large database, because you cannot have a 4 vCPU machine running heavy queries on a 20 terabyte or a 30 terabyte database, which is not going to be efficient. So you need to size it accordingly, so that your workload is able to perform efficiently, and you need to ensure that you size it based on AWR reports at the beginning of the exercise, and this needs to be done during the performance testing. So those are a couple of pointers which you can take from this session, and ensure that you follow these tips. So if you are migrating large databases, because these are very helpful, so that you don't run into common overlooked issues, and you don't run into problems when you're migrating databases. So I leave these links in the description, and I'll share these links later on. So these are quite useful links if you are migrating from Oracle to Azure Database for Postgres. I'll share these links in the description, and you can have a read offline in case you're planning to migrate uh, from Oracle to Postgres. Thank you for attending the session. And in case you are in case you are interested to know more about Oracle to Azure Database for PostgreSQL migrations, or if you have a topic for discussion, feel free to reach out to me. I'll be happy to discuss. Thanks for joining the session.